Hello and welcome to the solutions for our sixth quiz of the semester. This quiz was all about sequences, and the first few videos are going to cover problem one, where we were given three different sequences that we were trying to determine whether or not they converged, and if they did converge, what they converged to, right? So this is why the instructions ask us to compute the limit if it exists. Okay, so we are given a sequence A where the nth term, okay, is going to be given by 3n squared over n squared minus 1. We aren't told exactly where it starts, but you can easily surmise that it should start past n equals 1, because if n equals 1, you'd get 1 minus 1 on the bottom, and then we're dividing by 0, i.e. we are kicking a puppy, and we don't kick puppies. So maybe it starts at 2 or beyond, but since we are only caring about the long run behavior, it's not really so important where it starts. Okay, can we determine what is going to happen to this fraction as n grows to infinity? So we play a pretty typical game here where we're going to divide the top and the bottom by the highest power of n we see, which is n squared. So let's try that. So we'll just do a little work on the side. So we'll say if we had 3n squared over n squared minus 1, and we're going to multiply top and bottom, if you like, by 1 over n squared. All right, so on the top, that'll cancel the n squared, and we get a 3. On the bottom, okay, we have to distribute n squared times 1 over n squared is 1, minus, and now we have 1 over n squared. And this is a lot easier to handle than the original sequence because we only have one position where there's actually an n, and that's this position down here. It looks like 1 over n squared. And we were told we could, without proof, use that 1 over n to the k for any positive k converges to 0. So this tells us that 1 over n squared is converging to 0. Now, we have all these wonderful rules about sequences. If you have two sequences that you add together, then you could take, and they individually converge. You can compute the limit of their sum or their difference or their product or their quotient. So we can actually just do this piece by piece. So 3 and 1 are just constants. So they'll converge to 3 and to 1. And this bottom piece on the right converges to 0. So we know that as n goes to infinity, this fraction is going to converge to 3 over 1, which is 3. Okay, so that is exactly what our A is going to converge to, is 3. Now, there's something a lot more general which is going on here, which is if we take a look at this from the beginning and we go, hey, what's the highest degree terms on the top and the bottom? You see, ooh, I got an n squared on the top and an n squared on the bottom. All the other stuff really won't matter except possibly a constant here. And so if we'd have just from the beginning ignored the minus 1, canceled the n squareds, and we would have gotten 3 over 1, which would give us the same thing. And that turns out to actually work amazingly. So anyhow, this is how we can compute this limit.